Okay, so welcome to the Virtual JBug. This month we've got Burr Sutter, who's coming to talk about IoT. So this month we're trying something a bit ambitious. So first of all, we're broadcasting live, which is always problematic in itself, but Burr's also going to do as a live demo, which involves lots of hardware. So if it all goes to plan, then we'll be doing well. So I'm going to hand over to Burr. Thank you for coming, Burr.
Thank you.
So if you could introduce yourself and kick off your talk, that'd be great.
All right, fantastic. Well, I'm going to do a screen share and show you guys the slideware. Screen share, click the button. Desktop. All right, here we go. And I already have a bunch of things running here in the background. We'll see how well it turns out because I do have a fair bit of hardware on the desk with me. Here's my little camera. You can see I've got a bunch of things, and that's about half the things that I have with me. So we'll get to that in a second. So let's just go into slide mode. So my name's Burr Sutter. I work specifically for Red Hat in the developers program. So at developers.redhat.com, I'm specifically an evangelist. I go out and talk to audiences as it relates to anything related to Red Hat technology. It might be something in the area of Docker and containers or microservices and DevOps, or it might be something in the area of IoT. But pretty much I try to cover everything within Red Hat land, which is fairly challenging. But we'd encourage you guys to sign up at developers.redhat.com. That's our site where we'll be communicating more of this kind of content out in the future. But let's dive right into this content. I think you're going to enjoy this piece of the presentation. If you don't, then we might have to have a conversation afterwards. So the real nut of this is we've been focused on software for quite some time. Most people here as an enterprise developer is in fact a software person already. And you've heard the famous quote from Mark Andreessen, software is eating the world. But if you remember like 10 years ago or maybe 20 years ago, depending how old you are, we used to actually have physical things. We used to make physical things. We used to transport physical things. We used to buy physical things. And some of us still actually participate in the physical world. But what's interesting to me is when I ask my audiences how many people here actually work for a financial services organization, whether it be insurance or a bank or something of that nature, or if they work for a software organization, it's the majority of the hands that go up. Because it seems like all of us now are only dealing in the software world, the virtual world, if you will, and none of us work for manufacturers or airports or big buildings with hospitals, and I think that's unfortunate. We need to get back out in that physical world. And this presentation is really all about how we integrate our software stack into the physical world. So hopefully that'll be a key element for you guys. Okay, so right on here on this side, we talk about real things, physical things. You can see on my left-hand side of my chart here, I specifically have this vending machine that you might see at a hospital. So oddly enough, at a hospital where if you need your scrubs, you need certain equipment and whatnot, you would use your badge, and it would automate the vending of that particular equipment piece or actual scrub, outfit that you might need as a nurse or a doctor. And this is all done through an automated system. And that's been out there for years. I actually know a guy who used to work on those things physically at hospitals. So that's an example of real-world physical things and interacting with the physical world. So software plus hardware, in this case, makes that solution work. And of course, they got to keep all the inventory control. They got to make sure that no one person is dipping too often into the vending machine to grab equipment or scrubs. And that's important to have, right? So your back office systems have to be integrated with this particular intelligent vending machine as an example. At the top here, I put a PLC. So these PLCs, we used to have a lot of, we still do in a manufacturing world. The idea is that these guys, these programmable logic controllers, sit out there on the big conveyor belt and on the manufacturing line, and they guide certain sensors and actuators with the actual person in that manufacturing setting. We have a ton of these things out there, and they're not currently integrated with our IT systems. So if in fact this guy right here determines that something is either out of whack or out of sync, maybe it's running low on inventory, there's nothing to alert the IT systems to kick off the ERP process and then go out and do a purchase order or whatever needs to be done to get the third-party vendor to produce the product that it needs. So integration of these things has actually been kind of challenging. I also like this one right here. It's my portable ultrasound machine. If you think of a huge hospital, this thing might get lost inside that huge hospital. And that could happen, and therefore tracking of equipment is also very important. It's actually one of the top IoT use cases you'll see right now for the industrial internet. The simple concept of track and trace of specialized equipment and specialized tools throughout a large physical space, whether it be a big warehouse, big manufacturing factory, or like a big old hospital or a big university or something of that nature. Large objects get lost, and these things are very expensive, and you'd like to be able to find those things when you can. I'll put the water pump up here, because that is the common example you see in all IoT presentations, is how do you build a smart water pump? Do you actually embed your sensors inside the water pump, and therefore you have to completely redesign the inside of it? And you also have to worry about things like, water does not help you in terms of electrical signal. How do you get the actual data off the device? And a lot of people talk about the outflow. Sense the outflow of that water pump, and you'll know if the outflow of the water pump is either rising or falling or stopping. And if it's stopped, you know you have a problem, because there's always supposed to be water flowing to that pump, as an example. But my favorite one here is this one, the Disney Magic Band. And if you've been to Disney World in the last couple years, you would actually get one of these magic bands, right? You would get one for each child and for each adult. It serves as your ticket now, as well as your key card to get into your room, get into the park. And if you walk into a restaurant and just sit down anywhere, they know exactly how to find you within that restaurant and bring your favorite food to you. So this is reported as being a $1 billion investment by the Disney Corporation. And it wasn't the actual band. These bands are giving away to people. It's all the infrastructure, the traditional enterprise infrastructure that had to get built out behind it, so that you could also read all the signals that are coming off these devices. And it should be noted there are actually two ways to communicate with the Magic Band. By default, it uses an RFID-like process, if not RFID. And one of the teardowns that I saw on it, it was an RFID chip in there, which requires you to actually physically touch the band to a device, like check in here at the door lock and touch the door lock with your band. But it also has an 802.15.4 radio, or sorry, a 2.4 gigahertz radio is a better way to say it. So therefore, they can sense you at distance. So you won't lose your child evermore at Disney World, right? They'll know exactly where in the park that child is, as an example, based on the 2.4 gigahertz radio and just tracking that telemetry. So there's a lot happening in this space, and we have to start thinking about it from a software standpoint. Where do we reach out and touch the physical world? So I use this chart here to kind of give some context. I often like having a little history in my presentations. I've been doing software development since the 80s, and back in the 80s, we actually had these big old mid-range computers or mainframe computers. You guys might have had a 5250 or a 3270 or a VT100 that you actually offered to your end users as an interaction device. And that, I call it CHUI, for character UI. It was just a simple block mode terminal in the case of 3270 or 5250. And it might have been a character terminal with actual ASCII characters hitting the keyboard. As you hit the keyboard, it also reflects it back in real time. In the case of a Unix machine. So Unix, not Linux back then. So we had character user interfaces. And when we had that, if in fact this plant operator here, you can see my little plant in my factory, if the plant manager determined that he needed new inventory to fulfill his manufacturing requirements, like he needed a new toner or a new component part from your product, he would physically go back to his desk, look up the phone number of the sales rep for that vendor, and this guy here in my tie here, all right, and the sales rep would take the order over the phone, type it up or handwrite it on an order form, fax that into the headquarters, where a person would actually data entry that into their mainframe system. And that was a traditional business process in the CHUI world, right? 3 different humans involved, multiple opportunities for error, lots of interactions between the different parts. And then when we got into the 90s, we started learning about this thing called Windows, right? And we started rolling out Windows desktops and Windows laptops, and we had this client-server thing going in a big way. And what we did is we eliminated a lot of back office people. We allowed the sales rep to enter the order directly into a computer that he could take with him, like a luggable in this case, depending how early in the 90s you're talking about. But it had Windows on it, so he could feel somewhat comfortable by entering that order and directly pushing it out to the servers and pushing it into the system. Then we did the web, right? And the customer in this case could order directly, didn't need to call the sales rep. The sales rep didn't need to fax anything to a back office person. And now some of us have moved into the world of the mobile solution. So instead of this plant operator coming back to his desk and entering the order in his web browser, while he's out in the plant, as he's walking by the machine that needs the actual inventory, he can then use his mobile phone to order the product that he needs, and it'll go directly out to your cloud-hosted servers. And so a lot of enterprises are moving to basically this level of streamlined order processing as an example. And what I'm talking about here in the case of the Internet of Things is you can eliminate all the humans, because the machine in question will have sensors and know exactly how much product it needs and when it needs it. And based on the mean time for fulfillment, right, how long it takes to get the fulfillment done as far as making the order and getting it actually shipped to the new plant, it'll determine when the order should be processed. It'll communicate directly with your cloud servers, and the order will happen automatically. And as you hopefully can see in these series of steps we've gone through, by eliminating people and eliminating human error, hopefully we've gotten more and more orders more correct more often. We've streamlined the process. We've made it more convenient. We've made it faster and less error prone. But when we get to the actual things talking to things, well, then we have Skynet, and we have to worry about Terminators and things of that nature. So I know some people are paranoid about that, but that's kind of where we're focused today, is how making physical things talk directly to enterprise architecture, enterprise IT. Okay, so on this slide, I really want to kind of point out that IoT developers are going to be in high demand. So IoT developers are kind of a special engineer, if you will, and hopefully as we get this presentation, you'll see what I mean by an IoT developer. But Vision Mobile put together a survey, and it shows that there will be the need of millions of new developers in this space. And this is important because in between 2015 and 2016, where we are now, there is an estimated 1 million embedded developers today. So embedded engineers are people who primarily write a C, maybe they do FPGAs or something of that nature, and they really know how to do embedded engineering. But in many cases, that 1 million hasn't done connected embedded engineering. And we need it to be connected. After all, this is the Internet of Things, not just things. And so we're going to need a lot more people entering this space, according to Vision Mobile. And you're going to basically see a huge push, if you will, for people who understand embedded engineering, connected applications, and of course all the enterprise infrastructure needed to capture the data coming off these devices. Another chart here, I picked out a LinkedIn, interestingly enough, from Alok. Got his name out here, and I would recommend reading that article. I wrote a blog about it because I thought it was a pretty nice article that he put together. But he sees a convergence, and I believe in the same thing, of mobile developers, people who understand mobile applications, and understand Objective-C and Android Java and things of that nature, maybe even Cordova-based JavaScript applications, as well as enterprise application people, right? People who understand enterprise architecture and how to integrate with enterprise systems, and thing developers, so those embedded engineers who know how to do connected things, smart things, and we're going to see all those coming together. And then that person in the middle there is the sweet spot, someone who gets all of those technologies, right? They understand traditional enterprise architecture, they understand something about embedded engineering, and they understand something about mobile, because often you'll see the mobile phone as a key part of the architecture in this case, in many IoT settings. So I titled this presentation, The Journey. So here's the journey, and you can see on the journey right here that we're going to start with the Arduino. And in this case, this is how I started a couple years ago. I started playing with Arduino, and Arduino by default is not a connected device. When you first got into Arduino land, it wasn't a connected device, but you can make LEDs blink, and that's pretty cool, right? Everybody likes to turn on LEDs and make little servos turn, and maybe have a little light sensor or a sound sensor or temperature sensor, and that's fairly to do in Arduino land. And the cool thing about Arduino is if you can think of the problem and you type that problem into Google, say Arduino interested in sound sensing, you will find an answer in almost all cases. That's what I love about the Arduino universe. Most everything you can think of has already been solved. Then you have the Raspberry Pi. And so while there's lots of other parties in the Arduino land, the Raspberry Pi land, if you will, Raspberry Pi being the Linux land, I have another slide later that talks about several of these things. This is the journey that I followed, right? Learn a little bit about embedded programming, writing C code, if you will, for the Arduino. Learn a little bit about embedded Linux on small devices like the Raspberry Pi. And then you got to learn how to solder. In my case, I learned how to solder literally last year and started soldering things that I have here on the table with me. And I certainly had 20 years of enterprise architecture, so I had to figure out how to bridge those worlds into my enterprise architecture, and we'll see that in the demonstrations that I have. And then I went out and made friends. So this may sound weird, but I used to tell enterprise developers all the time, you know what? You need to make friends with your DBA, otherwise they'll never let you fix anything in the schema. And you need to make friends with your ops team, otherwise they'll never let you actually set anything in production. In this case, you now need to make friends with electrical people, electrical engineers, embedded engineers, and mechanical engineers. And here's one thing that I think very funny. In every audience that I present to, I will ask for a show of hands. In this case, it's hard to see you guys, plus you might be watching this from a recorded perspective. But you'll find that a lot of people are actually electrical engineers in our industry. Software pays better than electrical engineering and mechanical engineering. So a lot of people join the software universe when in fact they actually have a degree in electrical engineering. We need those people to kind of dust off those electrical skills and get back in the game, because that's what the IoT is all about. The bringing together of software and hardware and electrical components in addition to the mechanical components associated with the sensors and actuators. In any case, I'm kind of at this point in my journey, right here at enterprise architecture, just connecting all those dots, getting my little demonstrations and stuff working. But in theory, once you've actually designed and got it all hooked up, you could box and deploy that thing. If I wanted to, I could ship a Raspberry Pi in my own little box out to my user base, out to my plant, out to my vans or hospitals or whatever it is that I'm trying to enable. But that's not, I wouldn't say that's going to be a common case, but it is possible just to take the existing development board that you might have found from Texas Instruments or NXP or whomever it might be, Freescale, and just put it all together and box it up and ship it. But what most people will do is actually go through the PCB design process. So this is the printed circuit board. These guys right here are printed circuit boards. That's what those are, right? The card itself that sits underneath there. And you'll design your own unique circuit board that has just the things you need on it, and the sensors, and either the surface-mounted sensors or the sensors that are built right in, basically everything codified, if you will, into the design of the PCB. And then you have iterative cycles with these different organizations. So Sunstone and Osh Park and others, you can send your design to their website, and it'll print the actual board for you and send it, in some cases, within 24 hours. Sometimes it takes 2 or 3 days. And it might take $10 or $20 or whatever, but they give you your board that you can then get back to your house, solder on anything else that needs to be soldered on, and then run and test that system. So that's how you would iterate in this hardware world. Literally, they would print the hardware, if you will. They produce the hardware and then send it to you in a FedEx package. And once you have those iterations done, you feel like you got it awesome and right. You send it out for mass production. Probably it goes to China. And then you may have to go through a certification process where you might actually have to have, if it has a radio, right, you have to get approval for that radio because you have any kind of radio emissions. And then you're off to the races. You now have created your awesome home automation solution or some sort of product that you're going to try to sell en masse. And it might be you're just trying to deploy that product out to 1,000 vans that you have in the field, 100 trucks, 2,000 registers, cash registers, or wherever you want to deploy it within your organization. I'm going to leave FPGAs alone for now, but with an FPGA, a field programmable gate array, these things are getting very popular because when they've been very popular, but you can basically essentially design your own chip architecture with one of these guys. But we'll keep moving here. We don't want to run out of time. Okay, so here's the architecture, the high-level architecture, and I'm going to demo some of this architecture as well, so it makes some more sense. But you can have sensors out here on the far left, and your sensors are going to read. They're going to read the physical world. And that's actually how I like to think of it. I like to think in terms of read and write because I'm an old-school database person. So your sensors read the world, right? They inspect the world. They look at the world through any kind of optical, sensor, any kind of touch sensor. I've played with all sorts of sensors that you just put pressure on them physically or pressure on them from a barometric standpoint, or heat or cold or all these different things. And many of those sensors now can run on batteries. They don't have to run on batteries, but mine do because I like having things to be more portable. And then that sensor will communicate over some form of network into some form of gateway or an aggregator, if you will, that's bridging the gap between the sensor world and your enterprise architecture. So the gateway basically just serves as some form of communication tool. It might also have some intelligence at that gateway to do additional processing around the data packets that are coming through, like only send through sensor readings that are interesting, right, by filtering out all the noise. I don't care if the temperature has not changed. I only care if it does change and which direction it changes in. That's the data I want to report up to our ingestion engine. So you need to have some form of highly scalable ingestion engine. Typically, we think of this as a messaging architecture, but it might also be a time series database because you need to be able to feed in, potentially hundreds of thousands of transactions every second or every couple seconds just because there's just that much data flowing in from the various sensors you have in the field. And I have worked with some companies and spent time with some consultants working in this space. And literally, if you have smart meters as an example, and you have 1 million homes with a smart meter for your utilities, and those smart meters are reporting in every few seconds, well, think about it. I got 1 million of them reporting in every couple seconds. That's a lot of transactions flowing into our system. And then you will have to decide how you ingest that level of data, raw data in many cases, in a very high volume fashion. Once you have ingested the data, meaning you've absorbed it, you've held it, it could be in memory, but in many cases it's got to get pushed out the disk as well, just because the volume's so high. But then you got to run analytics on it. You might have real-time analytics to make real-time decisions, like the temperature is rising rapidly, I need to make a decision about that and react to that. Or it might be long-term analytics, batch analytics. So this is your Hadoop world in many cases. So in my demo, I use Apache Spark for real-time analytics. But you could also have batch analytics and any kind of form of analytics. It doesn't really matter. Some people like Splunk, some people will use Elasticsearch and things of that nature. But there are a lot of ways to do analytics. And those analytic engines will then feed your dashboards. They'll feed your workflow engines, right? So you can get people involved, temperatures rising, get people involved, find out why there's a problem, alert them on their mobile phone, and maybe you have some form of integration process as well. So if the temperature is rising, send off a notification on the mobile phone, integrate with a third-party system or another system to basically, order a new part, because temperature rising means that part is failing. Order a new part and get that part coming into our system. So think of that as the read side. Then there's also a write side. Okay, so read from the world through sensors, and then interact or write to the world, impact the world, physically touch the world through actuators. And so control messages can flow back out of this entire architecture, back to that gateway, and then out through some form of control panel, and maybe say, turn that fan on, right? Turn that light off. And that's an example of actuation, right? Where you're literally making a change in that world and having an impact on it in a physical way. Now this is where you definitely need to think about, you definitely need to be thinking about having your security a little bit tighter, right? Turning fans on and off could be problematic. That actually might cause real damage to a human or to your environment or whatever it is that's going on in that world. But you do have to think in terms of layers of security and having better security depending on what your needs are. So for instance, if I'm controlling a traffic light as opposed to a little CFL light bulb there, I need to have vastly better security as an example, because that could have real impact on people in the world at large. And if that traffic light is actually controlling trains, again, I don't want two trains to run into each other, and that's an actual use case that Red Hat has been working on. If you go to the Red Hat website, we've been working on positive train control here in the US, so trains don't run into each other anymore. Well, you got to have vastly better security in that scenario too. Okay, and I put this little bus up here at the top of my architecture chart because there also could be direct feeds from the outside world directly into your ingestion engine, directly into your message broker, time series database, and that's typically coming through some form of direct Wi-Fi connection, right? This thing has a Wi-Fi chip on it, or if it's like the bus running around the world at large, it has a 3G chip on it, so 2G or 3G chip. And some people say, hey, what about 4G LTE? Actually, from what I've seen in IoT space, people are happy with 3G connections. And there are other people out there who literally just send text messages, SMS messages, because they just need to send very small data packets back into the system from all their bus fleet or tractor-trailer fleet. You don't actually have to have a full-time LTE connection. And there's a lot of innovation happening in that space, too, for these really kind of high volume from a node standpoint, right? Let's say we got 1,000 buses on the streets, but relatively small data packets just coming in infrequently. I want to talk a little bit about edge architectures because this is really where it gets interesting. As I mentioned earlier, your bus might have a 3G connection, but you also have a lot of devices that can be directly connected through Wi-Fi, right? So there's a ton of activity in the Wi-Fi space, and I actually have a couple Wi-Fi items I'll show you here in a moment here on my desk. But I've also been experimenting heavily in the Bluetooth space because I do see a lot of activity in Bluetooth. There's a ton of good dev boards, a lot of good information to hook Bluetooth-based sensors into your gateway, and then from your gateway out to your cloud architecture. And I have several demos of that too, some of which I should be able to show you today. And the next one that I see is growing, though it's not really there yet, is the 802.15.4 mesh network technology. And then, of course, you'll put 6LoWPAN over top of that, and then you'll have CoAP perhaps on top of that. And so basically where instead of having a point-to-point connection between the base router or base gateway, the devices can route packets through each other until it eventually makes it to the gateway, sometimes known as a border router, and then from that device out to your cloud architecture. So I'm pretty excited about this rightmost architecture here on my right side of the screen with 802.15.4, but I have to say I have not put a lot of hands on it yet just because the hardware is harder to acquire compared to the Bluetooth hardware and the Wi-Fi hardware, which is ubiquitous, cheap, buy it every day at Amazon and eBay these days. This stuff is much more specialized and requires typically more firmware understanding and truly embedded firmware development in many cases. No one's really made it easy yet, is my point. I'm waiting for someone to provide an easy development platform for that. All right, so this is the world of electronics at a high level. We have microcontrollers on the left-hand side and then embedded Linux computers on the right-hand side. And I make that distinction because some people get these confused, and I have to admit, when I first entered this space, and if you're entering the space right now, it would be very confusing. It seems like there's a million new developer platforms that are available to you, new maker platforms and hobbyist platforms, as well as developer platforms. And every big hardware vendor is providing new kinds of hardware. And it seems like every day on Kickstarter, there's a new startup providing something new and cool out there. So let's just kind of walk through a few of these. I have some of these on the table, but we'll walk through some of the ones I don't have with me right now. Like the Tesla is pretty interesting, right? For $39, you get a JavaScript-based microcontroller, and it also has a connect. It is connected. It has Wi-Fi built into that. And it should be noted, by the way, if you love Wi-Fi, which many of us do, because that's how our laptop works, right? That's how our cell phone connects to Wi-Fi connection. Wi-Fi burns battery fast, but Wi-Fi is not the best solution for a disconnected device, like a wearable, as an example. Bluetooth is way better for wearables, and actually I do have a middleware with me today, but that's an example of a wearable platform that you would specifically embed in a wristband or a jacket, shirt, or belt or something, and then you would have the ability to use Bluetooth to bridge to the person's phone and then back to the cloud from the phone. So, some of these are very notable. So I have middleware, I'll show you in a second. I have a TI sensor tag with me today. I do like the electronic imp, met the CEO of that company, very neat guy. They've done a great job. That's basically the size of an SD card, by the way. The thing you put your photos on from your camera or slides into your laptop. I mean, that's amazing how tiny they've been able to make that Wi-Fi chip and the microcontroller built into one. One that's really tearing up the world right now, are really sparking a ton of interest, is this ESP8266. So basically, it's a Wi-Fi chip. It runs just a little bit of Lua or C code, and I believe people have also made a little bit of JavaScript run on these guys, depending on which version of it you buy. There's many versions out there now. But basically, it's a chip with a Wi-Fi. You can see the onboard antenna there. That's what the little gold squiggle is. It gives you everything you need for a connected microcontroller for $4, $5, $6, and that's if you buy one. You can get them cheaper if you buy masses of them. So a lot of people are really super excited about that because it's by far and away the least expensive connected Internet of Things device that you could possibly start programming with today. I do put the Uno on here because it's what got this whole party started in my mind. So because the Arduino Uno was both open source hardware and open source software, a whole lot of people are benefiting from that. So even people like the Light Blue Bean are a great example, or the Particle IO, they're benefiting from the fact because they can basically reuse a lot of the Arduino infrastructure to run on their hardware platforms. So it's been an amazing journey from the Arduino universe. Like here's the Pro Mini. It's basically the size as two postage stamps sitting side by side, right? Again, a tiny little platform. But these guys are not connected by default. Now you can add an ESP8266 to your Arduino. That's certainly possible, and some people have certainly done that. That's very popular. But you can kind of see that these guys by default are not connected. So on the right-hand side, I actually have my Edisons here. Those are some of my favorite guys right now. We'll talk more about those in a second, but for $50 you get Wi-Fi and Bluetooth. I certainly have my Raspberry Pis with me. Those guys are awesome. And for $35, right, the Raspberry Pi Foundation lit the world on fire. That's the easiest way to say it. A couple of years ago when they delivered the Raspberry Pi, the original one, the world freaked out because for $25, $35, whatever, you can now have a real deal Linux computer in the hands of everybody. That was kind of the mission, and I certainly applaud that mission, and it allows us to actually use that embedded Linux, running Linux on that thing, and then running Node.js and Python and C code and Java code on that little device to do all kinds of very clever things. And you can see the spine along the right-hand side of the device here, those little pins. That's how we interact with the physical world, right? That's how we hook up our digital sensors. So the Raspberry Pi is an all-digital device, while these guys on the left-hand side have for digital and analog. The Raspberry Pi is all digital, which can be a little bit troublesome if you try to hook up an analog sensor. In many cases, it's just very challenging. A couple of ones I'll just call out here before we flip over to the desk. I've failed to fill out my Kickstarter form correctly, so my Onion Omegas did not yet arrive at my house. I'm going to go back and do that, but that's a Kickstarter one. Again, another small embedded Linux platform, and then of course you can write code for it just like you would with Node.js or Python, etc., C or Java. And then another one that's just coming out, and this has changed the world again, CHIP, $9 Linux computer. So these guys got the ball rolling with $35 computer, $25 computer, $9 computer, and now you have to think about those terms. These prices falling to the floor. So let me break out of here. And let me switch to my camera. Okay, not that. All right, so don't need the grid. So here's my camera. Here on my desk. Here's my hand. And oh yeah, so while we're talking about super cheap Linux, this is the new Nano. That's the Raspberry Pi Nano. It has a couple. It does not come with a pin soldered on. You got to add those yourself. So it's a little bit different than the old Raspberry Pi, like you see here, where I have it in a case, but the pins came on it automatically. But this guy's $5. So the race to zero is on. 35, then 25, then 9, now 5. So I'm waiting for the $4 one or $3 one to come out soon. But think about that, right? These guys, these embedded Linux platforms continue to get cheaper, and they're quite powerful. And what you can do with them, there's a lot of things. There's a lot of things you can do with them. One thing I'd call out, if you buy Nano, by the way, it has a couple odd things about it that might definitely mess you up, and it causes a lot of people some grief. And that is, it uses a mini, not a micro HDMI, but a mini HDMI. That's the mini HDMI. And therefore, you need an adapter to bridge to your HDMI cable. So I got one of those here. And then also, their USB. They have a single USB connection. This is power, and this is USB right here. And this USB, of course, uses this little micro USB connection. I forget what it is, micro B to, the USB-A. But you need something like this to basically hook it up with the rest of your world, to your hub and everything else. So if you don't have those two extra little gadgets, then it can throw you off. You won't be able to connect to it and do the things you want to with it. By default, though, this guy does not have Wi-Fi built in, and it does not have any kind of Bluetooth or anything like that built in. So he's not a connected device. You've got to add a component. And you can see on my other Raspberry Pi here, I have a Bluetooth chip right here, Bluetooth chip, and then a Wi-Fi chip through USB. That's how we normally do it. So let's show you a couple other things here on the table. Here are my light blue beans. You can see in this case I soldered on a button. These guys are basically Bluetooth-enabled Arduinos, and you can see how small they are. And you use the little proto board to solder on what you want. So this is my Bluetooth-enabled button. I can do anything with that button. It's an anything button. It's pretty awesome. I can send off emails, tweets, launch a space shuttle. It doesn't matter, because all it means is when I hit the button, it sends off a signal, and then I have to interpret the signal and do what I will with it. I don't have it hooked up right now. You can see there's no battery in it, but I just want to show you that. This other bean I set up as a light sensor, so that's actually a little photovoltaic, maybe I'm not saying that right. Basically, it's a light sensor, and it's an analog resistor. And you can see we have another little resistor in there, and then it's wired in, and then it's soldered on the back, and so I did that. And then you just put your battery in there, and you're ready to go. So basically, you then connect to this guy via Bluetooth, and he's off and running. And what else do we have here to show? Oh, so here's my middleware. So I really like this guy. And actually, let's see if we can do this real quick. Let's see if I can bring him to life while we're sitting here talking to each other. And let me see. What I'm doing is I'm going to a phone app, because most of these gadgets work off most of these Bluetooth devices have a phone application that allows you to work with them. Okay, I'm not doing this too well. Let's see. On the mobile phone, you can't see it over on your side, on your screen. I got to get the right application up, if it would let me. There we go. All right, let's see if we get connected here. Connected to device. I got to hit the button, I think, to turn it on. And connecting. We're going to connect to this little gadget. You can see how small it is, right? So it's got a little battery hanging off of him and a pulse sensor. That's what pulse sensor is. And the little battery. But I'm just going to connect to the little board here. The pulse sensor you can solder off if you want to. I probably shouldn't have got it added on there. Let's see if we can make it flash green. Flash green, see that? Flash red. So I'm connected to it via Bluetooth, and it's on its battery. But you can see how this little guy has tons of stuff in it. Temperature, accelerometer, barometer. I want to know how many times you tap it. Is it flat or is it spinning? A gyroscope, so you can basically see all the different, all the movements that they might go through. So you can imagine you could stick this in someone's belt buckle if you needed to, and then track all sorts of things about them. You also have GPIO pins, right? So you can interact with it, solder on things to it, and that's exactly how the pulse sensor was soldered on there. So you can do a lot with this guy, and it's about $50. I'm going to turn the LED off, not so I don't get battery. But I really like him. You can see you would just have to figure out how to package him up, and that's meant for wearable technology. And you just flash it. There's a little USB connection there. And then this guy I really enjoy. I've spent some time with him. This is an angel sensor. So these guys have been so cool. They've gone out and basically said, okay, we know people want to build wearables. Let's just have a Fitbit, if you will, with an open API. And so this guy right here, again, you can connect to it through your phone or bridge it through your various devices. But it will do both oxygen sensing, temperature sensing, movement, step counter, things of that nature. A lot of things that you would normally do with a wearable device you would give to your grandmother or your aunt or uncle. And then, since it has an open Bluetooth API, you can program against it and capture all the data yourself, which is just totally awesome. all the other guys in the field in this space have proprietary architectures that you cannot talk to. So I really love the Angel sensor. It's about $150, I think, for the dev kit. And you can just look for angelsensor.com, I think is their website, to grab one of those. But let's show you a couple of other pieces here. Oh, this is the ESP8266, at least the version of it that I have. And if anyone wants it, I can give you the link to this. I think this one was like $5, and I had to come in from China, from Electro Dragon. But again, a very inexpensive Wi-Fi enabled chip. It's an awesome little guy there. And we'll show you these other guys are part of the demo as well, so we'll show you that here in a second. Okay, so let's jump back into presentation mode. So that's my little show and tell. Okay, some things you want to be able to do. Develop your inner maker, right? So remember I said earlier, you might have an electrical engineering background. Well, guess what? If you do, you probably remember these things called breadboards from many years ago, back in the dark ages when you were in college. You know, remember you had long hair in the 80s and Metallica t-shirt? Well, we had breadboards then, and guess what? Breadboards are back because you use those as your prototyping solution to connect all your wires and gadgets to see if, in fact, you can make the physical world talk to your software world. Learn how to solder, right? Start understanding things like volts, amps, and watts. I have to go read on those every now and then myself. There's lots of ways to communicate to the hardware world. Serial connections are by far and away what most people use, but I2C or I2C is the proper way to say it, and SPI. These are different ways to actually interact with that device in some interesting way. You'll want to work with resistors, maybe capacitors. A shift register is also very popular because that's how you would actually shift from, let's say, 5-volt logic, 3-volt logic, which is going to be a fairly common paradigm based on the devices you have on your board, right? Different sensors and actuators and different motor drivers and things like that you would have on there would have a different voltage level it responds to, and use a shift register to basically go back and forth between those two worlds. And then I call out the sensor page here on SparkFun. And by the way, all these images, I believe, I took them all from SparkFun. I love that site. But I mentioned earlier, you know, you have to kind of decide, well, what can you do? Well, you can do almost anything. Here's a great LiDAR module. I have, you know, accelerometers here. There's a distance and gesture sensor. You know, is somebody moving in front of my sensor? This is a flex sensor. If you bend it, you get different degrees of, it's an analog sensor, so you get different degrees of readings based on its bend. This is a pressure sensor or force sensor, so how hard is someone putting pressure on that disc right there? Temperature and humidity. I mean, just think about it. Fingerprint scanner, RFID reader. This is a waterproof temperature sensor. There's a gentleman I know over in Newcastle who specifically was wanting to put one of these in his pond to see how his pond was behaving, and I need to get back to him to see how he did with that project. But you know, just think about all the different things you could possibly do, and you know, soil moisture sensor. SparkFun has something for everything. You have to use your imagination and kind of say, well, what do I want to know about the world I live in, as an example. So go check that out. And let's see, I think the next thing here are some demos. So let's show you this demo, and I'll walk through it briefly here on the slide, and then we'll walk through it in the real world because it is a little bit confusing. There's a lot of hardware parts here, right? So there's a TI sensor tag via Bluetooth is sending temperature data to this Intel Edison, right, who's running Node.js, grabbing that temperature data and sending an MQTT message to Apache ActiveMQ running on my laptop, the same laptop running this presentation. I then have Apache Camel grabbing that data and doing some analysis, just real simple stuff. Is the temperature hot or not? Is it hot or normal? Is the basic idea. And then, by the way, the MQTT data is also being streamed real-time via WebSockets out to the browser, and we're charting it real-time in the browser with just some simple JavaScript. And then there's another Intel Edison listening in on MQTT, and he decides he's listening in for those hot or normal messages, and if in fact it's hot, he instructs the light blue beam, again via Bluetooth, wireless here, so everything's wireless and everything's battery operated, to move his servo. If all goes well, the servo starts turning when it's hot. So that's a quick explanation. Let's see if we can actually make it run. Let's see here, and let's bring up all the component parts. Okay, so I'm going to bring up my Camel process here. Let's bring up this is the Intel Edison. So this Edison is this guy right here. And so this is the one I'm interacting with right now. So I'm going to start the process. I'm going to come to my TI sensor tag and click the button so it turns on. So this sensor tag, that Edison, this window right here. So he's grabbing temperature data from that sensor tag. Okay, so if I watch what happens if I put my hand over it. So notice the temperature jumps up, 28 degrees, and put my hand over it, jumps up again. So it's using an IR temperature, which is in these, I forget which window it is, the left one or the right one, so I just cover both. And then that's a really nice piece of kit, by the way. This is $29, has 10 different sensors in it, Bluetooth out of the box, ready to rock, connected to this Intel Edison who's on my Wi-Fi channel. And by the way, I bring my own Wi-Fi router. So this is my backup one. The other one's plugged in. But I bring my own Wi-Fi router to make all this work. Otherwise, it gets kind of magical, and it gets harder to figure out. Oh, I'm a little bit fuzzy here. How come I need better focus? There we go. Okay, so he's reading temperatures. This guy and this guy are talking to each other. You can see it showing up here in my, so this is my message broker running over here, and then this is my camel process, and here is my browser process. Okay, so you can see the temperatures flowing there. Let's make this a little bit smaller. All right, so again, let's put our hand over it. You should see it spike up. There we go. See the graph spikes up there. Fantastic. So now we need to get the other process started on my other Intel Edison. So that's this one right here. All right, this guy. And let's see. Let's see if his node will connect. And he's going to connect to this light blue beam right here with all this funky wiring. So he's connecting to him. So he's got an extra battery pack. That's what he's wearing there. Because whenever you drive servos, you need to have additional juice. By default, most microcontrollers don't have enough juice to drive a physical thing like a servo. This guy right here, this little servo. But let's see if that worked. I don't think he got connected correctly. Let's try one more time. And it might be that my battery or something is having some problems. So let's see if it'll get connected. Okay, there it is. I can tell it's connected now because of the green light. I programmed that into the firmware myself. So I wrote the code for this device. So turn on the green light when it does get connected. Now let's see if this works. All right, so we got our hot or not running here. Let's move this over here so you can see it. And move this over here so you can see it. And if all this goes well, if I put my hand over it, it gets hot. It goes to hot. And then the servo goes crazy. See it dancing there? So a simple little example, but there's a lot of things showing here, right? So basically, messages flowing from the TI sensor tag, from this guy to the Edison, out to my message broker running on this laptop, through Apache Camel running right here, into my message graph, dynamic graph, and then out to this guy right here that basically says, move that servo when it gets hot. So let's try it one more time. So put my hand over it, see if it dances. There it goes, dancing away. So that's an example of a full end-to-end system in a very small piece of kit, right? It's all running right here with my little Intel Edisons. You know, I can see how small they are. I love the fact that with the SparkFun battery on them. By the way, the Intel Edison is just this little chip, the green part. The red part and everything else is the battery from SparkFun. So that's just an awesome little Linux computer, and you can see I've SSH'd into them, and I can make them do some magic there. So I really enjoy working with those guys as an example. All right, so that's that demo, and I'm gonna basically let's shut these processes down, and I want to show you one more demo. I'm actually going to just unplug him, move him off to the side, and I unplug him because he's also a Bluetooth device, and he actually causes a little bit of challenges in my next demo because he reports in as a Bluetooth device. So we're going to pull his battery out. Okay, and where are my slides again? I want to go back and just show you another diagram of what the next demo looks like, so you guys have an idea of what we're doing. All right, so the next demo is basically involves 2 Raspberry Pis, not 4. I did have 4, but I just set up 2 today. And there's 2 Raspberry Pis that will specifically try to read Bluetooth signals from around it. So the Raspberry Pi has a Bluetooth reader and a Wi-Fi chip, right, a Wi-Fi USB, and it's looking for Bluetooth signals. So any Bluetooth signal would work, but it's specifically looking for these Bluetooth beacons, low-energy beacons. So Bluetooth low energy. These guys run inside a battery. The gimbal will run for about 5 days, 4 or 5 days. The Estimote sticker will run, in theory, up to a year. I've only had them for about 2 months now, and they've still been working. So we'll see at what point they run out of gas. But what happens is, based on the proximity to these various stations, these Raspberry Pis, it's capturing readings, pushing it off to ActiveMQ, and then Apache Spark is looking at all the data from all these different Raspberry Pi readers or scanners, and based on that, it's determining which one you're closest to, and are you checking in of one and checking out of another. And the idea is you put these in different rooms, like in hospital rooms, library rooms, manufacturing rooms, whatever they might be, and as this device moves closer to here, to here, to here, it's making a calculation, and then of course we're drawing a picture to indicate where it is. And so we have a small version of it working. Let's see, well, let's see if it is working. Okay, so that guy is sitting out there. Let's see, yep, he's still processing. And so this one is sitting right here beside me. Okay, good. Looks like he's working. So if you notice, we have a little LCD screen here that says hello dog, and that's because my little Estimate sticker here has a dog on it, so I mapped the number, the Bluetooth unique identifier, to dog, so you can see it says hello dog. And if that is working correctly, you can see Apache Spark running here in the background. I'm going to also bring up my real-time console. All right. So this is a technology that Brian Leatham built for me. Did a phenomenal job. It's just totally awesome. But you can see what's happening here with the message broker. So messages are coming in, Spark is chewing them up and determining that there are check-in or check-out events. You can see the red versus green. And then we have a real-time map. Okay, so right now, I'm sitting in this physical position, if you will. That's what this guy is right here. Okay, so that's this guy. And then I have another group of these beacons on another scanner sitting outside the room. So let me go grab, let me see, so that's number 2 here and number 1. So number 1 is here, number 2 is here. So I'm going to go grab the beacons and pull them into the room, and let's see if everything moves correctly. Without knocking down the ticket. Okay, so here are my beacons. I got a whole bunch of them here. And you can see, should see a bunch of check-ins, and you should see them moving over to that forward position. Okay, fantastic. There they go. So Spark is now figured out that these guys are closer to this Raspberry Pi scanner, and now they're all moving, and you can kind of, if I open up the box, you can see them in there. So there's an example of basically real-time tracking with a simple cheap beacon, and using Raspberry Pis as a way to track them. And so in this case, it thinks I left one out there, and I might have dropped one. But that's the idea behind it. And using that basic technology, so using that simple technology of beacons and Raspberry Pis to track the movements of physical things, we actually built a demo. Scott Stark did a phenomenal job. If you remember Scott Stark, he's very famous in JBoss world. He's one of the founding fathers of JBoss. This guy totally rocked it out and built us this awesome demo. And this is the visualization that Brian Leatham put on top of it. And basically what it is, we had Raspberry Pis set up throughout Red Hat Summit this past year. So if I hit play here, you're going to basically see what happened throughout the day. I recorded this off our real-time dashboard, our map, if you will. And you'll see that people show up around 9 o'clock in the morning for breakfast. And then about 10 o'clock in the morning, they leave the 3rd floor to the breakouts down here below. So they move throughout the day, going from breakout to breakout to breakout. You can kind of see them moving there. And you can see how they move specifically from one room to another to another. And you can also tell that during breaks, right, that's when most movement happens. And about 1600 hours, 4 o'clock in the afternoon, they all start showing up for the keynote itself. So you will see them all move up to the general session on the top left there. So everybody leaves the breakout rooms. We had 300 beacons in play, by the way, and we had a couple dozen Raspberry Pis. And Apache Spark did all this processing in real time. And then we had a visualization just like you see here that we showed during the live session. After our keynote, then you can see people are leaving the building all throughout the day, and I recorded this at the end of that same day about 10 o'clock at night. So you can see people leaving the building, and maybe there's a few stragglers left inside the building as an example. But that's a whole day of processing. We processed over 7 million events, and with these beacons, with these Raspberry Pis, we were able to track that level of detail and movement throughout that day at the conference for our presentation. So that's what I was trying to show you with all those beacons and things like that. That's what we're trying to get out of those guys. And again, this is such a simple concept. Raspberry Pi running, in this case, Vertex code. So Scott originally did it with C code, but now it's actually migrated and moved over to Vertex code. Cool enough. And you can kind of see it's responding to my different beacons. Hello fridge, hello bike, hello chair, hello bed. That's what I have here. And then just add a Bluetooth dongle, add a Wi-Fi dongle, and you're off and running, right? And that's just running Raspbian. We didn't do anything special with it. Standard Raspbian Linux that you find from most Raspberry Pis. And that's how that demo works. So at this point, let me find the slide deck again because I've got too many windows open. Let's see what else do we have to do from a wrap-up perspective. We'll get into question mode. But again, remember, become a Red Hat developer. We want you. Sign up today at developers.redhat.com. And if you guys have questions, let's see if we can figure out how to make questions happen here. Or let me go find the right window. And All right, let's see if I can hear you guys. I'll turn off the screen share too.
Can you hear us? Can you hear us all right?
Yeah.
Oh, that was great. Thank you very much. That was really, really interesting. So, any questions from the room?
What's Bluetooth low energy like in terms of how long your button cell lasts? I mean, obviously it depends how often it's transmitting, but relative to Wi-Fi, what sort of magnitude of improvement do you get?
So if I understand the question correctly, you're asking about Wi-Fi versus another one of these technologies?
Bluetooth low energy. I mean, for sensors, the Bluetooth low energy.
Oh yes.
Yeah.
Everything I did here was Bluetooth low energy based, so Bluetooth 4. So that's primarily what you'll find in most of these kits, whether it be the wearable kit, like QB, or the TI sensor tags, or the Intel Edison. It's Bluetooth 4 based. And we, of course, we bridge Wi-Fi to get into your laptop in this case, or out to the cloud. And the other technology I would look at, though, is 8254, but that hardware is starting to come out.
Just a question here.
Oh, I'm sorry, please go.
In terms of the standardization about some of the features, for example, what you have on the gateway, is there some kind of just because, let's say, in enterprise application servers point of view, there is a standardization, even though there are many vendors. So do you see a point wherein the industry leading that way, wherein there will be some kind of a standardization about those gateway and then subsequently passing those messages across various physical elements?
Okay, I think it's a very fair question around standardization and exactly what will happen in this space. I believe what you'll see is standardization of protocols, and you have seen some of that, but MQP is being a very popular protocol, primarily what I demoed here today. Some people will use AMQP as well as a messaging protocol. Some people will use CoAP, which is essentially HTTP over low energy networks.
Yeah.
So you would run CoAP on 6LoWPAN, which works great over 804 connections. I do expect a lot of people to take that on. So you'll mostly see standardization around protocols, perhaps some security protocols as well. But I don't necessarily see standardization of like an app server-like thing at the gateway tier. The gateways will be unique for every use case. In other words, because you're going to have to bridge various protocols depending on what your needs are. A lot of gateways, for instance, will have Bluetooth or 802.15.4 inbound, and outbound to the mothership will be a 3G connection, right? A cell phone connection. That's going to be a very common paradigm, especially for your buses and trucks and trains and things of that nature that are physically moving around the world. A 3G connection makes no sense. So it really will depend a lot on what your use case is and the different parameters you're working within as to how you architect that gateway. In my case, I just use simple Node.js on my little things here, just because I just was trying to bridge from one world to another. Just a little Node.js script was all I was running. But what I would do in a more robust setting is probably put Java, and actually the beacon tracking system is Java-based or C-based. And then you would also have maybe a message broker locally. So if, in fact, you have a disconnected, connected kind of scenario where your gateway might get disconnected from the internet, you could use a message broker for store and forward, right? So it would basically keep messages locally until the network connection to the internet shows back up, and then it can route messages out to the cloud itself. So it really will depend a lot on your use case. I don't expect an app server-like specification to happen in the gateway space.
So I had to mute to stop the echo from happening. So we've got a question from Mr. White in the chat room. So he'd like to know, is there any, the demo that you've just done, is the code available online? And building
yes.
And so on?
All this code is available. Some of it's in my GitHub account, depending on Light Blue Bean, TI sensor tag, the stuff I do with Edison's, stuff like that. I have Raspberry. I got all kinds of crazy stuff that I've tried. But the actual beacon tracking demo is mostly under the middleware. So there's 2015 middleware keynote account on GitHub. But if you email me, I can get the URLs together for you. But it is all out there. So like the Vertex code specifically that runs the beacon tracking is out there for sure. The C++ version of that's out there. Scott has open sourced all of it and put it out there. So we do have it all out there.
Okay, so how about if you can give me the links, I'll put them on the vjbug.org page near the abstract.
Okay.
And then we can, it's probably a sensible place to put it. Along
Even
with the slides
even
as
the
well.
cool visualization.
Pardon?
Cool visualizations like the real-time map and all that, the real-time RxJS application that I showed you there, that's all open source too, right? So if you want to see how that cool JavaScript stuff works with real-time data feeds, so that's a WebSocket coming from the message broker going directly through Node.js out to the browser to draw them, basically move the balls on the map, right? And we're tracking each one of those balls individually. In the case of Summit, we had 300 individual balls we were tracking, each with their own life cycle. And Brian did a great job basically making sure each one of those is individually addressable inside the browser, and you can then physically see it move and change color depending on the status of it, as an example. And that's based on RxJS and a Node.js application that's also open source and out there in that 2015 middleware keynote GitHub account.
Excellent. So you did an extended version of that demo, didn't you, in the middleware keynote at Summit? So at Red Hat Summit, in the middleware keynote, you showed that demo and also kind of a longer version and an additional demo. So there's a video that you can watch on that, and it's currently advertised on the front of the developers.redhat.com homepage. So Burr, are you able to just bring that up on your web browser?
Let's see. And Scott and I did a deep dive session at Summit, but I know that recording has been available. Screen share. Yeah, so here we go.
Yeah, so on the homepage at the moment, there's a picture of Burr. If you click on that, it'll take you to his demo. Alternatively, if it's not there when you're watching this video, then you should be able to get to it from. Oh, here we go. There's the code here.
I was just going to GitHub account too. There we go. But that is the YouTube video recording of that specific demo.
Yeah, and you can also, if it's not on the home page when you're watching this video, you can get to it. You can search for it under /resources. There's a resource link at the top where you can find all our videos are under there, along with code samples and various other things. You probably can't read it at the moment because the resolution's a bit low. No, I can't read it anyway.
We can make it bigger.
On my laptop, actually.
There we go.
But I would highly recommend watching that video. It was very entertaining, as all the middleware keynotes are at Summit. They seem to get more ambitious every year, don't they, Bear?
Yeah, we got other crazy ideas for this coming year. But I don't. It will be a challenge to do more or crazier than what we did this past year. Because this past year, you know, we wired the Heinz Center up with Raspberry Pi-based sensors. We tracked 300 moving people with Beacon. No one's ever done anything like that before. You know, using that kind of technique for tracking people. And then we also did that, you know, launch 1,000 containers live on stage. We literally launched 1,000 app servers live on stage, and then had individual audience members claim their container, right? Claim their app server, and it all worked. And so we showed off a ton of infrastructure, a ton of actual real-world Internet of Things, and of course we had a mobile application integrating it all with a mobile backend through the Feed Henry acquisition. So it was quite adventurous. The fact that it actually all worked on the day it had to work, I'm still pretty overjoyed with, because it was quite a challenge getting ready for that event. A lot of all-nighters by the team. We had a fairly large team working their butts off to make it all happen.
Yeah, it was definitely good. Definitely what we were watching. So any more questions, people in the room?
Alice, whether you have any comments about wired versus wireless. One of the nice things about Ethernet is that it can support power of Ethernet. So instead of needing batteries and having to keep recharging depleted batteries, the cabling infrastructure can carry both the data and the power. Some devices necessarily have to be untethered, and so mobile's a good solution. And I think it's where one is appropriate versus the other.
Yeah, so when it comes to power over the internet, I think that's over Ethernet typically. I've not seen too much wireless power yet in production. There might be some out there, because everybody's doing everything at this point. But typically power is over the Ethernet cable. That is definitely something I've heard about people doing, but it doesn't work with the Raspberry Pi as far as I know, which is the device I'm working with. So that would be entertaining. I need to see if That'll be a good feature for them to add. But most people do need to be untethered with their sensors, not their actuators typically, but definitely their sensors. And that's what I really love about the TI sensor tag in particular. It's a great example. I'll just bring that back up of a kit, right? So it's a dev kit that you buy for $29, and you can take it out of its rubber jacket. It gives you a nice rubber jacket. But this little board has an accelerometer, a gyroscope, barometer, magnetometer, light sensor, sound sensor. It's got 10 different sensors, and it just runs off that little battery. And they'll tell you that this kit, if you play with it right, and you write the code for it. By default, it comes ready to work, but you can flash it yourself with your own code. That's what that little socket is there for. I have the debug kit in my bag. But in theory, it'll last months off that one little battery. And basically, because it's Bluetooth Low Energy, it'll last a long time. Now, that's what they claim. I've not pushed it that hard, but I've also not changed this battery in 6 months either. But I only use it for these kind of presentations. I'm not using it all the time. So that would be an interesting test to see, if I ran this on a reoccurring basis. Because what you would do is, using your Edison, right, or whatever else that you're bridging to it with, you would pull this guy, right? So you, from him, connect to him every so often. And if they actually look at my light blue beam code here, and actually I have the code up, let's pull it up. It's used the Arduino. You can see on my light blue beam code, this is probably super tiny, so let me zoom in here. I have the bean enable on wake, enable wake on connect. That basically means he only wakes up and absorbs power when you tickle his Bluetooth radio. So there's a lot of good technology now with aggressive sleep cycles that basically says, don't even turn me on until something hits my radio, and then that causes the rest of the system to kind of wake up. And so Light Blue Bean has that feature, and TI, of course, I've not looked at it closely, but TI says they do things like that too. That way you get so much power, or so little power consumption, and therefore you can last on a battery a long time. But does that answer your question? Does that help?
Partially, I'm thinking the use case that we're familiar with for powered devices on wires are desktop phones, where the line is supplying the current to drive the phone. It sounds impressive that battery-powered devices can work that long. And perhaps security is another consideration. So you gave an example of people walking around the JBus Summit. And perhaps without authentication, if some of those people are mobile security officers and they're there to make sure things don't get stolen, it would be possible to intercept just the device MAC address and work out. I'm clear because the security guards have identified they're in another room right now, so I can just steal this. Is there a solution to that, or are there these concerns?
And I don't really know if I personally have an answer. I certainly have not tried to lock these things down because they're just my demo components specifically. But I do think in terms of security and layers, right? And you also have to decide what is the benefit to the attacker or hacker if they do get in. So if you have $1 million behind the door and you have a screen door with a little latch on it, someone's going to take that $1 million, right? Because there's enough value there and so little security there that it's easy for anybody. Even an honest person would step through that door and grab the $1 million and walk away, right? Not even a thief. So you do have to decide exactly what the value is that they might be taking, right? And then based on that, how many layers of security do you put around that? So you can definitely have secured communications across these wireless protocols so that it's an encrypted communication, but it is challenging for some devices. Like I mentioned that, where'd it go? This guy right here is a great example. So he supports Wi-Fi, but he has such a low-powered chip on him, he can't set up an SSL connection. He can't do HTTPS, right? He can only do HTTP because he's so low-powered. He just doesn't have that big a brain. So I can't remember. I think this is a 32-bit device, but it doesn't have much memory. So a lot of these guys just don't have enough horsepower in them to do complicated encryption, as an example. You also have to worry about if the person, let's say you put up these guys at the local shopping mall, right? And that's where these sensors are setting. Someone could just rip it off the wall, right? They just, they can rip it off the wall like that and take it away, and then they're off and running with it, and they go home and they can figure out, they can figure out what the firmware is on it, and then rehack it, flash it again, and then put it back at the mall, and now it's, of course, sending data to some other person that it shouldn't be. So you do have to think in terms of physical security, wireless network security, Can it be flashed again? Some of these devices now are going to be tamper-proof, so if you did peel it off the wall, it would physically break the device, and you wouldn't be able to flash it again with new embedded code. So you just have to kind of consider all those things and really consider what the value is to the theft. Is it worth $1 million? Someone's going to steal it and break it, right? If it's not worth but $5, he's just doing it for fun. It's not worth much to him. So you just have to kind of think those things through. At least that's how I think of it.
That's very good. I'm just thinking, without taking the effort, let's say you couldn't break whatever security was on there. Could you, in fact, without obtaining the payload, the fact that you could spot the devices coming back again today, some shopping malls are doing it when you log into the Wi-Fi. So Cisco have partnered with a mall to look at the movement of customers around the shopping mall.
Oh, yeah. Yeah, exactly right. So what's happening like in the phone industry, my understanding is and I don't know if it's iPhone 6 or iPhone 6 Plus, but basically it will randomize the MAC address so people can no longer track you through your phone. Now, a lot of Android phones don't randomize the MAC address, but I'm sure that'll be a common thing where all the phones will randomize the MAC address. And one thing I'll show you here on my phone, because I think it's so fun, Apple Store. So if you have the Apple Store app on your phone and you walk into an Apple Store, this is what it looks like when you're not near an Apple Store. But when you're in an Apple Store, it'll actually welcome you to that store. So right now it tells me this is my closest store based on GPS location. If I walk in that store, it'll say, welcome to the Crabtree Valley store based on a beacon, right, another Bluetooth beacon, and this mobile application. And then you get a barcode scanner where you can actually do the shopping right here on the phone. And you can scan the device on the counter, pay for it with your thumbprint, because this has the thumbprint reader, and then you basically walk out with the product. You don't actually have to talk to a human. So the retail people are going to get crazy in this space, right? They're going to try to track your phones. They're going to try to track your Bluetooth devices. If you sit on a plane, like I have a Bluetooth scanner on my phone too, if I sit on a plane, I can see everyone's Fitbit on the plane around me. So Bluetooth, it always has a unique identifier that it's emitting as part of its advertising packet. And that's how it does its pairing, right? If you pair to a headset, you pair to a keyboard, pair to the Fitbit, it's kind of an always-on advertising packet, and that's exactly how we made it work for the Bluetooth tracking we did with the Raspberry Pi. So if in fact these things really worry you, you need to make sure there's, all these devices have left your system and you didn't swallow one, because at some point they'll be, ingestible. And they already have that, right? You have an ingestible device that connects to a patch on the outside of the skin, which then has the Bluetooth connection. So the Bluetooth radio is on the outside of the skin. It has a smaller radio between the pill and the patch. I mean, it's just going to be crazy. There's no more privacy.
Thank you.
So, thanks, Bert. We've got another question from the chat room. So, I don't know how to pronounce this, but I'll give it a go. So, are you seeing some products using LoRa, maybe LoRa radios in the IoT space at this time?
I haven't seen a lot of LoRa stuff. So LoRa Alliance here. So this is very cool tech. But I haven't had a chance to play with any of the hardware. And let's see, for developers, let's see if they have hardware. One of the challenges you'll find in this space is putting hands on hardware is actually still kind of hard. People love to put up web pages, but you can't actually buy the hardware. And I have not actually been able to purchase up to this point. I'm looking now, see if there's anything here. How do you buy LoRa hardware and play with it? I got all these other things here on the desk with me, and this is only about half the stuff I have. I have a whole bunch of other stuff at home. But, how do you actually grab it? So I'm personally very interested in it. Basically, it's, wide area networks. So going across a city, going out through a big farm, right, a big manufacturing location. But I've not had a chance to touch it yet. It is very interesting, though. There's also the Sigfox guys that are, basically doing something similar. And I don't know if this is specifically 800 or 900 megahertz, but there's a ton of activity in the 800, 900 megahertz category. So Spark, Fun, Zigbee. So there's Zigbee radio specifically in the 800 megahertz world. And so that is a booming space right now. So I'm trying to see if I see it here. But these guys will have multi-kilometer wireless network connections because they use that 900 megahertz band. Most everything else you see on the table today for me, actually everything on the table is 2.4 gigahertz. Everything's 2.4 gigahertz. Bluetooth, Wi-Fi, all 2.4. Even your 802.15.4 is 2.4 gigahertz. But the fact that you can use this 800 or 900 megahertz area, and I think that's maybe what the LoRa guys do, gets interesting. But I can't remember which one of these it is. Is it this one? I've forgotten already. That's 2.4 also. But they do have options in that space, and SparkFun can sell you some of those things. Okay?
Yeah, I think that answers the question. Yeah, again, something else that looks interesting. So any more questions, people in the room?
Do you have any opinion where IoT should not enter? So, like, I read an article recently about a company making a connector for CAN bus, so plugging it into your car and it would give statistics via 3G onto a web interface, so you could have a look. I don't know, presumably when you get to the office or whatever, how many revs you've done over the journey of the over your journey. But there was also a vulnerability in it, and CAN bus is known to be quite vulnerable in itself. So you can do things like jam on the brakes or accelerate or whatever like that. Do you have an opinion on what sort of things should be put into the IoT space and what should stay out of it?
That's a very funny question, because I suspect because of all the people who are so excited about being in this new world. And so this is the maker universe, right? Not necessarily the enterprise developer universe, but the maker universe. And it is booming. It is exploding. And you got your SparkFun and Adafruit as your two primary, people and actually that's Adafruit.io, you got to go.com. So like they even have, Adafruit and SparkFun have their own cloud-based architecture for streaming up sensor data, things like that. I mean, there's nothing that's off limits at this point, is what I would say. And you have to protect yourself. Like, so the thing you mentioned with the starting, stopping, accelerating, things like that, that module I think is $29 or something. Buy it at Amazon or eBay. You plug it into the car. It streams Bluetooth to your phone, and you can do it all yourself. You can grab all that data yourself. That's an experiment I've seen a lot of people run, and I've just not bought the hardware and tried it myself yet, just because it's not that interesting to me. But that concept, and all concepts where technology will be incredibly invasive, is just going to happen because everybody is trying to make it happen. And we'll just have to protect ourselves, if you know what I mean. Or unless you want the government to shut down all innovation. That's another option.
Any other questions?
Yeah.
Yeah, I think we're all done here. So thanks again, Burr. Are you showing us something at the moment? Or?
And I said Raspberry Pi Nano. I meant zero. I got too many things. But that's the zero guy right there. So if you don't have a Raspberry Pi, you should have one. Every technologist should have 2 or 3 Raspberry Pi.
What's the spec difference between the Raspberry Pi Zero and the Raspberry Pi 1 and 2?
Well, I mean, it's a smaller form factor. It has less memory, less of a chip. But it still runs Linux. It still runs great, right? So from our usage standpoint, it doesn't really make a difference.
So is it more powerful than the Raspberry Pi 1, but less than the...
Yeah, slightly, if I remember the specs, but it's not as powerful as the Raspberry Pi 2.
Okay, makes sense. And does it have Ethernet on it?
No Ethernet. So, so this is Raspberry Pi 2, 4 USBs, 1 Ethernet, and this is the Raspberry Pi Zero. Basically, you'd have to bridge the Ethernet through a Wi-Fi dongle here, because it only has 1 USB connection, and then of course it has this weird HDMI connection, and that's where your SD card goes. And this is power right here. So it is a much smaller form factor, though. You can kind of tell, right? And you can embed that pretty easily in a piece of plastic and ship it to somebody. You just got to add whatever other components you need, whether it be Wi-Fi, Bluetooth. You should be able to pull Bluetooth through here as well. And then you wouldn't need HDMI once you package it up, right? That's just for getting it going. Typically, I set all mine up as headless, right? So this is headless. I don't need to ever plug in a console to them. Because I use a trick. Since I'm using my one Wi-Fi router, everybody's programmed to look for this certain SSID, right? And I can then see the IP address of everybody and an SSH into it. That's how I get around having a monitor and keyboard with me wherever I go. So that's just a good tip if you want to play with all these things. Get your own router. $50 on Amazon. It's a battery-enabled Wi-Fi router. It does Ethernet bridging and Wi-Fi bridging. That's exactly how the stream is working right now, bridged through the other one, through the corporate network. Alrighty then.
So that battery-powered router that you've got, so it bridges to some other Wi-Fi network. So you can bridge it to like your corporate network at work, and then you can attach your devices onto it.
Oh, totally.
It's pretty handy.
You can see the one I'm actually on is wired. I physically wired it in, but you could also have Wi-Fi wireless bridge. Yep. It works vastly better on Ethernet than it does Wi-Fi, but I really do like these guys. It's a Hutu. I have 2 of them. I like them that much. And the battery will run for hours. I've run it 3 hours for a presentation before. So this one's still charged up. You can kind of see it's charged up there. And you can actually use it to recharge your phone if you wanted to. Kind of crazy what they can do with these gadgets these days.
Yeah, sounds handy. How much do those cost, roughly?
$50 on Amazon.
Wow. It's all, pretty much everything you've shown us is very, very cheap, isn't it? It's not an expensive hobby to get into, or even into if you want.
The most expensive option was my Angel sensor, because it comes prepackaged, ready to rock. Think about this guy. You could basically put him in an older person's home, right, where you're actually trying to, like my mother, I want to keep up on my mother. Is she resting properly, moving when she's supposed to be moving? And if you wanted to monitor 500 older folks, you could by just strapping that on. It's ready to rock. You know what I mean? So that's more expensive because it's a prepackaged thing. But the rest of these guys, you got to add your own packaging. They're cheap, right? Okay.
Yeah. Well, thanks very much. Any more questions? No. So we're going to go and have pizzas and some drinks. So thanks again for coming, Burr. And
pizzas for me?
Pardon? No pizzas for you. Sorry, no. You'll have to make do. It's not even tea time for you yet, is it? It's still lunchtime.
I missed lunch.
You missed lunch. Oh dear. Oh, I'll see you later, Burr. Thanks for coming.
Bye, guys.
See you. Bye.